I mean, more than 10 lines. But yeah, I could understand few problems what you guys are facing, like kind of you need more time to read the paper, right? We'll see. So like this paper, the title itself shows, right, the structurally tuned various types of nanoparticles for drug delivery applications. So if we spend some 10 minutes by reading this abstract, you can derive those structural property very easily. So you can see here, this work was like a preparation of hydroxide substrate by using co-precipitation method and sonic. It's a combination of both method. And then we have obtained two different types of mesoporous nanorods. Okay, one is small, sorry, one has very small pores and one has very larger pores. Okay, and which was played with the role of beta cyclodextran or cyclic polysaccharide based polymers. Okay, and then again this all these characteristics. Tools for confirming those things like formation of those nanostructured materials and formation of nano mesoporous structures. And then yeah, since I asked you specifically only the biocompatibility of the nanomaterials, so it's very simple. More the porous structures, you will have more biocompatibility or the cell viability, because if you don't have pores, the cells they cannot interact well actually. So if you don't have pore at all, then the cells, number of cells, which they can grow over the period of time, which is going to be pretty, very less actually. So that's it. So if you see the conclusion, so other steps, maybe yeah, you can read or you don't have to read. That's up to you actually. But yeah, if you see this figure, this is day 1 and this is day 3 and this is day 7. For the cell culture results. Okay, and you can also see here the optical density of the cells, like how much cells was grown over the period of time. So NRHA means Bristine hydroxide nanorod, which has no porous, and this is again beta cyclodextron wrapped mesoporous, nanorod based hydroxide. These two materials are nanorod and these two materials are mesoporous. So obviously mesoporous shows better cell viability, and again the microstructure also shows as compared to porous and non-porous material. Porous material shows cell architecture, microstructure. But yeah, eventually, like if we see the comparison between day 1 to day 7, again beta cyclodextran based, porous structure, like which has slightly higher, larger pore size, has more cell viability. Okay, so that's because due to that the cells they can interact more. Rather cells and materials interactions. And on top of that, the material itself has like calcium and phosphate ions, and they are tendency to enhance the catalyze the cell culture, cell grown. So yeah, that's it. And rest of the other stuff you don't have to worry actually. These two pictures you have to refer, and then conclusion and abstract, then you can derive easily 10 lines. So how long you need? Suppose if I ask you the same kind of cues, by giving you some papers. So you need more hours, more time. Means how long you need? 1 hour? Bharatwaj, how did you answer how did you write quiz exam? This.
Sir, time was not enough, sir. Otherwise, it was.
Okay. Okay. In that case, how long you time?
So, see, we were prepared for like MCQ and short answers.
Description.
So I didn't even keep a pen and a paper ready with me. I lost 5 minutes finding a pen.
Okay.
That's why, like, maybe if it told us before that it was going to be this format, it would have been a little easier.
Okay. But I cannot reveal exactly. Say, for example, the next quiz or the mid semester can be a combination of all. So in that case, the question may not be this much lengthy. Maybe of description format like 2 lines. Straight away, I'm going to ask you to refer so and so figure and so and so things are happening and why is it so. That's it. So in that case, you don't need more time, right? I'm
So
defining all
based on the
the.
number of pages.
Sorry, Ashutosh, you are trying to
Sir,
talk something.
the time you're talking about the time, sir. The time should be based on the number of pages. So that quiz has 13 pages. Like the paper you send had 13 pages, and it took a lot of time to just read. And yes, sir.
Okay. No. Ashutosh, that's what I'm telling. I understood. This is kind of, kind of surprise. You don't have to worry about this quiz marks. So I'll conduct 4 or 5 quizzes and I'll select the best 2 or 3. So you can forget or you can ignore this quiz. That you don't have to worry. But before that, what I want to tell you is that how to attend this quiz is very simple. Whenever I ask this kind of question, you refer exactly where biocompatibility is there in the paper, and the abstract, of course, abstract will give you the overall picture about the paper. What are the materials they have fabricated, or the kind of nanomaterials they have synthesized, and what exactly the result they have got, and what is the conclusion. Once you have, gone through the abstract, then you go straight away into the biocompatibility result, like MTT result as well as the fluorescent microscopy. So in that case, like things going to be very, kind of narrowed down, right? Hello.
Sir, actually, the issue is the fact that, sir, you sent us a quiz on Moodle, then told us to open on Teams and then send you a mail as the answer. So that was a little confusing in terms of using 3 platforms. For me, I couldn't like open Teams on. I had to go to another device and open Teams because I don't have it on all my devices, and there were things like that. So it'd be better if you could like keep everything on one platform. If you're keeping it on
Okay.
Moodle, please keep everything on Moodle.
But I think you are using phone or this one tab or what? If you use
So I have
laptop,
some
that
issues with downloading Moodle on my laptop, so I use my phone for.
okay. Yeah, that may be the issue. If you use a laptop, then that should not be the case. Yeah, it is fine. I'll take all these issues and maybe we'll resolve it. Okay. Okay, if you guys are not comfortable, we'll go for straight away the MCQ and other stuff. I don't have any issues, but yeah. Yeah, in that case, like I will see the next quiz or exam. I'm not going to upload paper straight away. I'll give you the picture. You refer the picture and then give me the comments. That's it. So I'll ask that like that kind of stuffs. So today we'll see about the metal matrix based composite preparation. Okay. Yeah, this you have seen, right? Interface formation and how to get rid of those. Getting the close interaction between the matrix and filler. All we have seen, right? Hello, Prakash, Om Prakash. We have seen, right? This interface formation, all these things.
So I didn't attend the last class, so I don't know.
Others, because I'm also not sure, so that's what I'm asking.
Yes, sir.
Ashit,
They did it till
okay,
here, and from next class
okay,
you told that we'll start from
all
metal
right,
matrix.
okay, all right then.
Okay.
Okay, so if the interaction is very poor between the primary phase or the matrix and the dispersed phase, how do you resolve it? Because if matrix and filler have a very good interactions or the interface formation is not there, so how do you will not get the desired properties? In that case, how do you resolve this to get the desired properties? Pooja?
Sorry, sir.
Say, for
I
example,
didn't
see,
get your
you are. No, if matrix and filler, if they are not at all having good interactions, how do you resolve it? First of all, why interaction is not there? Do you know about that? If your nanoparticle is pretty low, I mean very small size, means they will not. They have high tendency to get aggregate. Okay, so to get rid of those aggregate, you have to make sure that you are dispersing the nanofiller properly, as well as the distribution should be proper. So all those things, to be done. If we don't do that, then this matrix and filler or the dispersed phase, they will not have a very good interactions. That may comes from the aggregate point of view, as well as the surface charges. If we take polymer based on some kind of organic polymer, and you are taking some fillers, say for example hydroxide, it is hydrophilic in nature, okay, polar, and polar and non-polar, they cannot miscible each other. So what you have to do, you have to modify the surface of the nanoparticle, or you have to modify the surface of or the polymer chains of what you are using, okay, which is in non-polar. So somehow you have to play with those kind of charges or some sort of like hydrophilicity or hydrophobicity. By that way, you can have those, you can bring those better interactions between the matrix and the fluid. Okay. So that's what I given you the assignment also, like fabrication of nanocomposite by using different strategies. Okay. And you see, like you'll come across a lot of formulations, like a modified filler, how the property is giving in solution casting, and the same formulation in situ polymerization, how the property is coming. So you'll come to know all those things. Okay. So fine. So we do have a nanocomposite based on metal matrix. Okay. And which are widely used in the high performance sectors like aerospace and automotive, and in fact in the some of the biomedical engineering, where the implants, etc., because they are lightweight, of course, and they've got kind of combinatorial properties, like they've got excellent modulus as well as strength and elasticity. Okay. And it can, of course, if you use metals, you can use it for high temperature, and it cannot wear or it will not get corroded that easily. Okay. Of course, if you use some sort of like copper or some sort of corrosion resistant based metal or alloys. And most commonly, people use aluminum and magnesium, because if you see, other metals like steels and others, they are pretty heavyweight, and which is not affordable. For high performance applications. So in that case, like if you use aluminum, and if you use reinforcement, maybe of some aluminum nanoparticles or some sort of carbon nanostructures, maybe of CNT or other carbon dots, etc. So the weight is again going to be pretty, less, and you are not going to sacrifice any kind of properties. These are the few characteristics you get. The important properties you get by preparing this metal matrix based nanocomposite. So you'll have a combination of compression strength as well as the tensile strength, and yeah, of course, you will have a very good ductile material, and in high temperature mechanical property. That means your metals can be used in the high temperature, dynamic, atmosphere, like dynamic mechanical properties. And yeah, you can also use for wear resistance and scratch resistance, because if you use nanofiller, what's happening? So the stress will start to propagate. Very lately. They need more time to stress to propagate from one side to other side. So that's what, if you use some sort of two-dimensional nanomaterial like nano rod-based material, you will have a more resistance to to push those stress from one side to other side. I'll show you one example. Right, you see in the next application section. Fine, leave it. So these are the few techniques people quite often they use for preparing a metal matrix based composite. Okay, stir casting method and ultrasound assisted stir casting, and disintegrated melt deposition for preparing those coating based substrate, and semi-solid casting, and then the lastly powder metallurgy based route, like kind of sintering and compacting and ball milling technique, etc. So stir casting method is very simple. Very common method which we use for almost for all the metal. And yeah, of course, for metal matrix composite also you can use, where you are going to melt those metal, and then I mean you're going to add the reinforcement particle. Again, you're gonna keep it for some time under stirring, or kind of some using some impeller based stirrer. Okay, and then yeah, you can play with the role of either the stirring speed, I mean the rotation per RPM, as well as the viscosity, and the furnace where you are taking the the volume of the furnace, etc. So all those things will define how effectively the particle is mixing into the matrix. Okay. So if you see the metal matrix based composite, what are the nanoparticles that people quite often they use? They use graphene, copper nanotubes, and metal oxide based nanoparticles. That means some alumina, or some sort of sticker nanoparticles, etc. The one issue is that challenges are the key problem which people quite often they face here. Since the metal usually they used to melt it at high temperature, I mean above 500 degrees Celsius. Okay, and then yeah, we do use some impeller or some rotor to rotate those molten metals. Okay, once you add this reinforcement phases or the filler, so you used to rotate it at certain RPM. What will happen as a result? There will be a formation of various bubbles. Okay. So once the bubbles started to form, then you will have a lot of defect, or kind of some voids will start to form in the product where you are what you are going to fabricate. Okay, so once the voids or some bubbles or some defect then of course the property of what you are aiming, that you are not going to get it. So in that case, like people use some unit gases like argon or nitrogen to get rid of those gases. Of course, still there is high chances that you cannot avoid at all. So those are the few challenges. What people usually face actually. So in that case, like the rotation of those, RPM speed, as well as the furnace size, all these things are pretty important to get rid of those voids or kind of bubbles. So again, ultrasound assisted casting is method is nothing but the same that of same casting method what you have seen in the last slide. And addition to that, we used to keep some ultrasonic gun based ultrasonic gun in the furnace. Okay. Actually, instead of rotor here, they use ultrasonic gun. So in that case, what will happen? The ultrasonic gun produces some mechanical, stress or the vibration into the furnace, and as a result, this aggregate formation of those nanomaterials will be avoided. So as a result, these nanomaterials can disperse well in the matrix. Okay, as well as since we are not using any impeller or the mechanical rotor. Okay. So you are not going to get those kind of voids or the bubbles in the mixing furnace actually. So of course, yeah, this is slightly costly, but yeah, one has to be more trained as well, because if you see this metal and the ultrasonic gun, actually they are made up of stainless steel actually, most of the guns, and yeah, that should not get reacted with this metal actually. What you're going to melt in the furnace. So all these things are to be considered during this process. And we do have disintegrated melt deposition. Okay. It's a kind of process where we use kind of some to fabricate some sort of nanocomposite based coating substrate. Okay. First, the slurry we usually prepare. Slurry means it's a combination of metal and the nanoparticles. First, the slurry is prepared. By simple melting those metal on inside the furnace, and then you are going to put the nanomaterial, and then you are going to keep it the same furnace for quite some time. And then the slurry is then passed through the nozzle, kind of injection-based nozzle, with the help of, either gas like argon gas, etc. At so and so temperature. That depends on the, kind of material what you are taking. Okay, and that usually, deposited on the metallic substrate or the whatever the substrate you want to get it. So here the the viscosity and at what pressure you are going to inject those slurry, that is very important. And yeah, this can be movable. Okay, if we see that this one, scheme you'll get to know. So this is connected all together, all in one actually. So you can see here some of the furnace which are in the top of the panel, okay, and they are as same that of steel casting method. Okay, you're going to put the metals and then you're going to melt it and then you're going to put the nanoparticles and then again that will be rotated at certain RPM, and then yeah they're going to make sure that they are mixed well. And once it is mixed, and there will be a kind of forces with the help of either argon gas or something, you can inject these materials, I mean the slurry, and towards to the metallic substrate or the whatever the target where you are going to deposit. Yeah, and this can be movable, okay, and so that it can deposit throughout this surface of the substrate. And yeah, the thickness can be fine-tuned by using the pressure as well as how much time you are depositing, all those things. That's it. So, and then the last the fourth technique is called semi solid casting. Okay, and this also used actually because you see we have a different metallic nanocomposite fabrication technique, because all the nanoparticles you cannot process it at source temperature like 500 degrees Celsius, 600, 800,000. No, you can't do that because the structure will be collapsed, and structure means the base crystal structure as well as the physical structure, like kind of spherical or nano rod or some sort of three-dimensional structure. So once you are disturbing those nano structure, then you're not going to get the properties at all. So that's the reason why we have different processing techniques to have those different, of course, substrate as well as to have those, desired properties, without affecting the nanoparticles. So semi-solid casting is also one of the technique, kind of die casting technique, which we use for the fabrication of metal nanocomposites, and wherein here the process is called like the metal is injected into the mold cavity in a semi-liquid and or the solid state, okay, with the fleshy inconsistency, and we have here like kind of very less energy demands, and less porosity is more easily handled, and it requires less post molding machine than that of metal casting technique. Okay. So you have a plunger here, and then you have a metals here, and then you're going to push, add the nanoparticles, and then kind of compaction or the compression molding. So with the help of plunger, you can push all these metals, either slightly melted or kind of solid state. And then you're going to get the thin film kind of structures. Okay. So finally, the one process called powder metallurgy. Okay, so it's a combination of ball milling process and cold compaction and hot state extrusion, and of course microwave sintering as well. So basically, what it's called like kind of top-down approach means you're going to add macro or kind of micro matrix particles of either metal matrix, okay, and then on top of that you're going to add some nanoparticles. You can see some of the picture here. So aluminum matrix, that means aluminum microparticle is added, and then silicon nitride based nanoparticle is also added. So if you are using some ball milling process, straight away you're going to put these materials in the ball milling process, and then with the help of those ratio between the ball weight and the materials weight, you can able to reduce the particle sizes of matrix, aluminum matrix here. Okay, and with that time you can obtain those aluminum into the maybe in the very less small size of matrix, particle size. Of course, your silicon nitride is also going to be ball milled in the process to reduce the size, as well as they can also interact well with the matrix. So once the mixing is done, you can remove those material, and then you can take it for sintering, or you can go with the hot state extrusion, or you can go with a cold compaction. Just put those materials in the die and then push it with the help of any kind of piston, etc. And then you'll get those kind of either kind of thin film or kind of structured materials. Yeah, of course, if we use some extruded, I mean, hot state extrusion, again, you'll have to melt those two material, and then there'll be a ram which will eject those molten metals towards to the die. Then you'll get those, I mean, product upon quenching. Yeah, this is one of the, sorry. Yeah, it's the same kind of one paper. I mean, the what I have given you for the case, how the mesoporous structure is forming, how the nanorod size is getting increased when you add those beta cyclodextran based oligomers. Maybe that we'll see in the next class. Any doubt from this 4-5 process? Ball milling, you can see here. I don't know whether you have seen this process or not. Yeah. So this is how the ball milling, the machine rotates actually. So the big ball, that is balls, I mean, which is slightly heavier than the material what you are going to use. So the small that broken pieces, those are materials, maybe a combination of two material like aluminum and silicon nitride, what we have seen, and this one. So over the period of time, what will happen? So this ball will start to collide with the materials, okay? And since you are going to rotate, I mean, this process for quite long time, like 2 or 3 hours. So they get interact more, I mean, and the particle will be reduced, actually. The size of the particles will be reduced. And if you mix two particles, and what will happen, those two particles, they'll start to mix each other. We'll see, I mean, for the detailed process, we'll see in the next class. Okay, then if you have no doubt, see you tomorrow, day of tomorrow, sorry, Thursday.
Thank you, sir.
Yeah.
Thank you, sir.